In this lesson, we are going to make a motion detection alarm. Let's begin. So today what we are going to cover is infrared, the passive infrared sensor, piezo buzzer, and how to set up. Okay, so today's motion detection alarm. Okay, does it work? So the PIR sensor will sense warm heat. So when it sense heat, then what it does is that it will sound the alarm via the piezo buzzer. So the PIR sensor doesn't emit infrared. It just is sensitive to sensitive to infrared. So when the passive infrared sensor actually sense movement of heat, then it will do something. So it will sound the buzzer in this case. Okay, so what is infrared? Okay, there are different types of rays in this electromagnetic spectrum, and infrared is one of them. There is also the whatever we can see is considered visible light. So if you look at the spectrum, okay, the electromagnetic spectrum, the lights that we can see, the things that we can see is only here, this small range of visible light. Okay, so there is actually a wide spectrum that we cannot see with our naked eye. So infrared is one of them. So it's here. So if it's not hot enough, then it's not radiating visible light, it will actually emit infrared. Okay, so what are the uses of infrared? So if you have a remote, you can actually see the infrared. So remotes are basically emitting lights to see so that it can send signal. Okay, so this I have a remote here. So this remote is the infrared TV remote. Okay, so when I press this, if you are using an Android phone, you will be actually able to see the emit the you can see the infrared light is actually when you see from the camera, Android camera is actually purple. Okay, so it's actually sending the infrared signal via the light blinking on and off. Got light, no light, got light, no light. So we can't see this from using our naked eye, but you can actually see this using Android phone. Because Android phone don't have a camera shield to shield to the infrared. But if you do this on iPhone will actually cancel out. You can't see the infrared. So only works with most Android phones. Okay, Android phone camera you can't see with naked eye, but you can try this at home with any TV remote, aircon remote. You can try and use Android phone to see the infrared. Okay, so using remotes to control devices, this is one use of infrared. Another use of infrared is the infrared thermometer that we use to measure our temperature. Then there is also this device here. This is actually a device used in a hospital to actually warm up injured part of the body via infrared. So what it does is that when this is shine onto the injured part of the body, right, it will heat up the part, and you will feel aching. So it actually heat up so that it promotes recovery of the injured part. So this is used for physiotherapy. Then there is also the infrared faucet. So that there is a contactless, you can detect that there is your hand that is hot, is near to the tap, it will actually switch on the tap. Then there is also another use for infrared, which is the telescope. The telescope with infrared will be able to actually see through the dust cloud. So in this example, we can actually see through the dust cloud. So one example of an infrared telescope is the James Webb Space Telescope. So it is so powerful that you can actually detect a bumblebee. Okay, the something the size of a bumblebee. Okay, the heat of a bumblebee as far away as the moon. So it's very powerful because it uses infrared. Huh? So these are some of the users in our daily life, current users. Okay, so what other things can we do? Next, what are we going to use to detect the infrared? We are going to use a passive infrared sensor. So there is a pyroelectric sensor at the center. So we are going to look at it. I'm going to just open up camera. Okay, so this one, if you actually take it out, you can actually take out the Fresnel lens. You just need to slowly take out. Okay, so you can actually take this out, and when you take this out, you can see that the sensor here is actually sensitive to heat lah. So you shouldn't heat up. I don't think it will harm it lah, but I don't touch it lah. So just if it's too hot, it is sensitive to heat lah. So that's why you can see the infrared. So if you look at here, they actually show you the pin. What is the pin for? So you can see for here, there's 3 pins. The one on the left is VCC. VCC is a 5 volt, and then the center one is for the digital reading. So it's out. So it goes out from there, goes to your Arduino, and then you read it. So the left pin is 5 volt. The last pin is GND. GND is ground, so this goes to the ground of the Arduino, okay, or in our case Stuino. Okay, so this sensor is sensitive to light. So but then how do we direct light rays, the infrared from the side towards this, so that it makes it more useful? We use this Fresnel lens. So this Fresnel lens, it will actually help to direct the infrared. So if you can look at the diagram here, it shows you that you can direct the IR to the sensor, so you will be able to sense it. So this is so you know the pins, what are they for? 5 volt and ground, and the center one is the center one is for reading. Okay, next, how to calibrate the PIR sensor. So we can look at this video here, and you can compare it with the slide lah. So there is this cap here that will help to change the trigger mode. So this L mode is a low mode. So if you put the cap here, is a single trigger. So and then if you put it to the other side, is a repeat trigger. Okay, so what is single trigger, repeat trigger? So in single trigger, if motion is detected, it sets to low mode. This one is jumper setting, it's just some jumper setting. It's set to low mode, so it's single trigger. So when actually the most important graph is these two. So motion detected, okay, what it does is that once it's detected, it will actually output, okay, the set delay amount of time. Okay, set amount of time. So even if the movement is constantly detected, it will only output for a select a delay amount of time, same amount of time. Okay, movement can carry on, but it will only output the set amount of time. Even if it's very short, you also only output for the selected amount of time, okay, the time delay. Okay, but for the repeat trigger, okay, the difference is that, okay, the trigger is high mode. Okay, so it's jumper setting is set to high. Okay, so detect motion. What it does is that it will sound throughout the motion plus it will actually sound for the delay that you set, okay, the amount of time that you set. So it detect this amount, and after you continue to sound for the period of time. If so this is the delay that we have set. Even if it detect motion all the way, it will actually keep sounding until motion stop. It will do the delay. Example for here also, it will, even if for short period, it will alert, it will send out the output lah. Then after that it will continue with the delay. So there is a big difference between just this one. This one is only play a selected amount of time, but this one it will play more than the movement is there. It could keep triggering, okay, movement. As long as there's movement, it will keep trigger until the end of the movement. The last trigger, it will move, it will play the delay, okay. So there's a difference between single trigger and repeat trigger. So you should set it as a repeat trigger, because we are using it as a motion detection alarm. So as long as we detect there's something moving, it will trigger. Now the sensitivity, you can adjust the sensitivity by tuning the potentiometer. Okay, this is a potentiometer. There are two potentiometer on it. Then you can turn counterclockwise to decrease the range or increase range. So I'm going to decrease the range to 3 meter. Okay, max decrease the range, and then I'm going to max decrease the delay. So this is the delay that is for this time. Okay, the delay that we talk about here. Okay, this is the delay. So we are going to max delay the timing so that it doesn't trigger for too long. Okay, you can trigger a delay about 5 seconds to about 5 minutes. Okay, so the last delay, the last movement will actually it will sound for another 5 seconds if you decrease the delay. So my recommendation for this exercise is H mode repeat trigger. So when there's movement, it will keep triggering, repeat trigger. If there is, and after there is a max decrease range, so we don't need it to be covering such a long range, okay, and then we max decrease the delay. So short range, very sensitive sensor. So next we are going to look at this. Okay, so so I'm going to just remove this. So you can slowly take out the jumper, this one. Then we can just the cap to cover here. So like this is the H mode, H mode repeat trigger. Okay, so like this. Then for the potentiometer, okay, these two we are going to adjust them. I think I'll just switch off the lights, too bright maybe. So you should use if you can use your fingernail turn, you can turn it, but don't over turn it. You should just tune to, there is one part that will block it, okay, and don't force it. Okay, if your screwdriver is not the right size, then you change the screwdriver size, or you just use your fingernail to go and turn it. Okay, just be careful, don't go and so this cross, right, if you turn too hard later, it will damage it. So when I turn this, okay, well, I haven't turned it, I think maybe I switch on the light okay, good. So now you can see this number here. Okay, you can see the number here. So later I turn it counterclockwise. I'm going to turn it now. Okay, you can see it turn. Okay, this is the maximum. Okay, because this part the number part is blocked by one part of it. Okay, so that's the max. Then we turn the other one to the other side also. That's it. Okay, so turn to wherever you can turn. Okay, maximum turn, finish already. That's it. Okay, so we have adjusted, we have calibrated it to how we want it for this project. Okay, if other projects you may want to adjust the the range and the delay for your own project, or even change the trigger. Okay, next. Okay, there is a difference between the Tinkercad and SSTuino. So just now I show you that for the SSTuino, the out is at the center, and then VCC and ground is at the side. So if you can't remember, you can just easily just take out the Fresnel lens, okay, and you can actually see it from here. Okay, VCC out and ground. Okay, so if you need to, you can just take out the Fresnel lens and take a look. Okay, so if you look at the Tinkercad, is different. Okay, the reading the signal is actually the out is actually at the side, and then positive, negative. So if I create a new circuit here, turn off first. Okay, so if you take out a PIR sensor, type in PIR, okay, take out this, you'll see that actually the signal is at the side, and then power, and then ground. So it's different. Okay, so how you connect this is different. Next, okay, so later we are going to connect this PIR to the Arduino. Okay, so the first part is to set out the PIR sensor, and then to see how it works. But you will not be able to tune anything here lah. You will not be able to adjust the sensitivity and the delay here. You can't do that here. Okay, but yeah, you can't do it for this simulator, but it's okay. We can do it on the real thing. So we're gonna take this out, and then I'm gonna just use a breadboard. Okay, so we'll just connect it the usual way. Okay, then I will just connect this. So signal, I will read from 7, power, yeah, I'll go straight for this, and ground. Okay, so this will be red, and this will be orange. So maybe I'll just adjust this. Okay, then okay, that's it. I think this is good. Maybe I'll just adjust this also. Okay, and just make sure it's straight lah. Okay, that will do. Okay, so this is set up at pin 7. So code. Okay, so we throw away this, and then what we are going to do is we are going to just plug in. Okay, so what we want to do is we want to say if, okay, if motion is detected, so motion is detected, it will be high. Okay, so the reading here, if motion detected, it will be high. So this one is read digital pin 2, but I'm just going to read pin 7 later. So if there's no movement, it will be low. Okay, it will be low. No motion detected. Okay, only when it's detected, it will send to the board high. Okay, so if equal to high. So if read digital pin 7 equal high, then you output print to serial monitor. Okay, motion detected. Okay, done. So I'm going to just open this up. Okay, I'm going to just drag this down. So start simulation. Okay, so now it's like this. So when this you click on this PIR sensor, you'll see this, and when it moves, motion detected. Okay, when it moves, motion detected, move away. Okay, you move, it's not within range, it doesn't detect, you can clear it. Okay, doesn't detect, but when you move in, motion detected. Okay, so this is how you can, and you can see that when you move, you stop moving, it will still keep printing because there's a delay to this. Okay, but when it's still there, it doesn't do anything already lah. So I'm gonna move away, clear it. Okay, and I'm going to, okay, so other than printing serial monitor, you already learned that you can put in LED. So you may want to build in LED, put in a LED to bright light up the LED if you want to. Okay, other than just printing to serial monitor. Okay, so next we are going to do this on the real device. So I'm going to go back to here, and I'm going to just maybe I'll just light this up and going to do up the thing. So okay, so for this I think I'll just plug it straight lah. So I'm going to plug in the jumper wire. So we use the female to male jumper wire. Okay, so sometimes it's a bit hard, so you just slowly adjust it, see whether can poke it in if it's in. But sometimes it's a bit hard to get in, just slowly wobble, or if not, just change the wire lah. Oh, so next one, slowly adjust. Okay, go in already. Oh, so next one. Okay, all in. Okay, so this is to the ground. Okay, I remember. If you can't remember, just open it up. So this one is to the ground. Okay, so I put this to the ground, and then this is to 5 volt. If so, not following the colors if you want to, you can follow colors. And this will go to pin 7. Done. Okay, so we are done for now. Okay, so the next thing I'm going to do is I'm going to download this code. So blocks text plus text. So it's the same thing. So pin port 7 is an input. Instead of button, I swap out and I put in the PIR sensor. So if high, you put motion detector. So I'm going to just copy this. Okay, I'll just copy this, and I'm going to open up Arduino. Okay, you can either copy out or you can just type it out also can. So here maybe I'll just explain it for this video. Pin mode 7 input. Okay, but I think you try and type out. If there's an error, just copy and paste. So pin mode 7 input. Why do we have pin mode 7 input? Is because this one is to declare pin 7 for digital reading. So declare pin 7 for digital reading. So the pin mode is declared. Serial dot begin 9600. Start, or say transmit to serial at 9600 baud. Okay, done. Then this one, remember, must put semicolon. Next, void loop we will say if. So the structure for if statement is like this. Okay, so this is the structure for if statement. Okay, so from here, if what happened if digital read 7, if digital read 7, pin 7 is equivalent to high, okay, then what do? We will serial dot print line. Okay, sometimes I like to open and I like to close it first, then I go back in here and I open and close the text, and then I'll just type in motion detected. Okay, and you don't need the delay, okay, because the delay is for simulation. Let's get ready to upload this, but before you upload this, make sure that port is set. So this one I have not plugged in my board yet, so I need to plug in my board, and then it will prompt you to what it does. Okay, I plug in already. So it will prompt you to save the file, huh? So I just plug in USB modem 101. This is my phone. Okay, so it's a USB modem blah blah blah. The 101 or 1101, that is your Arduino. So I'm going to just choose this, and I'm going to start to upload. There, they will tell you to save it. So I'm going to save it on my desktop. You should save it to your ICT folder. If you have not created a folder, you should create a folder to keep all your things. So this is lesson 4. I'm going to put lesson -4, okay, and save desktop. And I'm going to open up the serial monitor. I'm going to go to here. I'm going to just put it to one side. Okay, skip this. So just wait for a while. Done uploading. So now it's not detecting. There's nothing. So it is not sending. Oh, motion detector. You see, I think there is the heat of the camera, I think. So I think maybe if I switch off this, I clear out the. Just going to clear out this output first. Clear output. Okay, motion detector. I think it detect my hand. Okay, so I'm going to clear output again. Okay, so it will be. Oops. So it will. Hold on, I just need to point forward. Yeah, I think I'll just point forward first. Okay, so let me adjust my camera. Okay, so I'm going to just keep it here. Okay, I need to point, try to adjust it further forward, and clear output. Okay, so never mind. So it is quite sensitive. You need to make sure that you put it at somewhere and there is nothing that is too hot. So it will detect after it's high for the set period of delay. It will be low for about 3 seconds. Okay, so if I put my hand forward, motion detected. Okay, clear output. Okay, 1,000, 2,000, 3,000. Okay, nothing. I put my finger forward. Okay, detected, motion detected. Okay, so this is how it works. So for now, we just do the motion detector. If you want to, you can go and try and play with the putting on the LED. Okay, so next. So once this is done, we are going to do our buzzer. So how are we going to do the buzzer? So the buzzer, how it works is that when you use this buzzer, so instead of print to serial monitor motion detector, we are going to I'm just going to throw. Actually, you don't need to throw this away. You don't want to. Output play speaker on pin. So we need to put in the speaker. Okay, we need to put in the speaker and how to do it. So the speaker, you just need to type here buzzer or piezo. Okay, piezo. So this is the one. So there's a plus minus now. We need to so the plus is for whatever pin that is going to send. So whatever pin you want. Also, you can plug it to any pin and then negative to ground. So this one, maybe we'll just put it to the ground here. Okay, so I'm going to just maybe put it here. Okay, so this is this. If you are connecting to here, then you make sure you connect the ground here. Yeah, I like to do it like this. Okay, so ground. So this is black, and this is black also. Okay, black. This maybe I'll connect it to pin. Okay, I'll just connect it to pin 8. Okay, so okay, I'm gonna put it here. Okay, this one will be maybe green. Okay, so this is how we connect the piezo buzzer. So let's explain this. So this will actually translate to this function tone 8523 1000. What does it mean is that it is saying that is playing tone on pin 8 503 hertz. So 523 hertz is another wavelength. So it's a wavelength. So C5 is actually 523 hertz. How do I know? Later I can show you. So and then 1000 millisecond. Okay, if you are you know piano, you can actually this C4 is actually the middle C, which is 262 hertz. So you can actually use Tinkercad to help you with this. So I'm going to just open this up. So if okay, I'm just for me, I'm just going to delete this. Okay, so tone 61 from here you can actually see okay, pin, I put it at pin 8, so pin 8. So the tone 8, pin 8, 523 hertz, which is it's from here. It says C5. If I'm going to put this at 62, it's going to change it. Okay, so if I put this as 62, is D. Okay, so put as 1 second. If I duplicate this, plug it here, 60. So maybe I'll just play do, re, and mi. Okay, then let's see what happened. So 64. Okay, 64. So C D E. Okay, C D E for 1 second. 1 second, 1 second, 1 second. So by right, we should expect do, re, mi for 3 seconds. Okay, so we'll try this out. Start simulation. Okay, and then I'm gonna just move this in. No, it sounds like crap. So what happened? How come it's not do re mi? Okay, the reason why is that the code will just run through all three, and it's basically running all three at the same time. Okay, all three at the same time. So it's only playing for 1 second. Okay, for all three, play all together. So what do we need to do? We actually need to, in order to hear it clearly for that 1 second, you should actually put in control 1 second. Okay, so it is going to play for just 1 second. Okay, it's not going to play for longer than that. So I'm going to just put it here so that it can cycle through. Okay, so when this command is given, it will wait 1 second while this is playing. Then it will go to the next tone. While this tone is playing, it's waiting 1 second to go to the next tone. Okay, so we are going to try this out. I'm going to start simulation. You can take your timer to time it. So I move in. Okay, so it is playing 3 seconds. And it is because it's not that it's going to play 6 seconds. Okay, if you look at the code, it's not 6 seconds. It's only 3 seconds, because while this command is given 1 second, it will wait 1 second before it runs the next command. Okay, so the next function. So if you want to play a tone, you can use this way to actually play a tone. So in fact, if you open up my website, there is actually another information. So usually people don't use that method to write because it's kind of tedious. Okay, So usually people will write it in this manner. They will write the melody first, then after they write the melody. So the melody is later I can teach you how to actually get this melody, because there is this library called Peaches.h. So the melody, then the duration will be translated, okay, to the number of seconds, okay. So they will put in the melody, the same amount of melody, the same amount of duration, then they will actually use another thing to another for loop to actually play this song. So this is a bit complicated. If you know programming, then maybe you can try this out, huh? If not, you are not so strong at programming yet, you still don't understand it, is okay. You can actually use the very simple method to do it. Oh, so there is this. So this is the Peaches.h, which is the library. So you can actually call out this. This is the note, and this is the frequency to call, hertz. How many hertz? 31 hertz. Okay. So later we will go through this. We will maybe go through a little bit of this from here. So maybe I'll open up the favorite song. Okay, favorite song circuit, and from the favorite song circuit, if you open up the code, okay, so this code this is a demo lah, huh? So from here you can actually play this start simulation. So you can see lyrics, and you can hear. And the LED is blinking with it. Okay, so this is a demo. So you can actually use this to play a song. Okay, in fact, you can actually find other songs from here. So you can find Super Mario, Pokemon. Okay, they can play using the Piezo Buzzer. So if you have played the Game Boy before, when I was young, a lot of people were playing the Game Boy. So the music is actually using the Piezo Buzzer. So if you do this on or maybe later we can do this in the video, you can actually play out the song. It is very much like the Game Boy. So I'm gonna close this. Okay, so we are gonna continue. So you may want to try to play Do Re Mi. So it will be written in this manner. Okay, and you can just adjust the duration and the tone. Okay, from here you adjust, you can actually play the tone. Usually we will not go down to the lowest tone lah. So usually we will use the middle C as a guide. So next, so just now I already play. I think when I move this, it play Do Re Mi already. So you can already see that how to play the how to make the motion detection alarm work. So if no motion detector, you may want to also add in a stop playing, but actually it will stop playing by itself lah. You don't really need to turn off speaker on pin 8 lah. So because it will cycle through here, so if not detected, nothing detected, you may want to turn off speaker. So this is if you want to. Okay, but as of now I think it works. Don't need to use the else statement to stop it. Okay, so this is how we do this for the simulator. We are going to try and connect on the circuit for this. So let's begin. Okay, I think this will do better. So like this. Okay, so I'm going to plug in the Piezo Buzzer. So how does the Piezo Buzzer look like? So just light it up. Okay, so this is the Piezo Buzzer. You can actually see a plus. You can actually see a plus here. Okay, so this is a positive. So this will go to the playing pin. Okay, then the other one will go to the ground. So there's 2 pins. Okay, you can see from here 2 pins. Okay, you can use the male to female cable also. So actually we don't need to use the breadboard today. So I'm going to use that. Okay, so I'm gonna pull this jumper wire and I'm gonna plug this in. So positive, this will go to, so hold on, again plugging pin, try and be careful, nearly poke my finger. So this will go to pin 8, then this, okay, careful, plug in, slowly adjust, okay, in. This will go to ground. So there's a few ground, I think 2, 3, yeah, 3 ground. So if you think it's too crowded, you can plug it to the one at the top. Okay, so 1, 2, 3, 4. So this is the one. Okay, done. So I'm gonna try this. So I'm gonna just go over here. Actually, I just need to say, okay, so I'm gonna just copy this. Yeah, I'm just going to copy this. I think it will be a bit irritating. Okay, but never mind. Just copy this first. Okay, so I'm going to copy and paste this into Arduino. You will notice that the delay is gone already. So the delay for the simulation is gone already. It's actually quite clever. It will actually remove that delay. So we are going to upload this. So if motion is detected, it will actually sound. So I'm going to put my hand. Okay, I'm going to do this again. So my hand just now just go near it, it will actually sound the buzzer. Oh, just for a short while. Okay, good. So this is how you connect and then you sound the buzzer. So this is our motion detection alarm. Okay, so what other things can you do? You can actually connect a button with the piezo buzzer, then you can make a doorbell. Yeah, digital read the button, and after you read the button, then you can actually sound the doorbell. So you can actually put in the music for the doorbell. Okay, so maybe I'll just go and get the, I think I have the Super Mario. Maybe I can just oh, detecting. Okay, let's see whether I have the Super Mario with me. Yep, I have 1, 2, 3. I'm gonna download these 3. Okay, my hand just go near it, you sound. I'm gonna plug up. Okay, I'll plug out already. Good. So I'm gonna open up this. Okay, and maybe the first one I'm gonna play is Super Mario. So open up Super Mario. Okay, so Super Mario puts into the folder. Okay, so now we should look at this. So this one was downloaded quite a while ago from the internet. So it says integer speaker pin 8. So it's saying that the pin for the speaker is pin 8. So our speaker is already on pin 8. Okay, so I'm just going to plug in and then flash in this code. So I'm going to plug in and upload now. Okay, so the Super Mario works. You can actually go and find online. You can actually download this. So I'm going to close this. We'll open up the Pokemon. Okay, I'm going to plug up. Okay, too noisy. So the Pokemon, I'm gonna just look at this. So these are the tones that are used for Pokemon. So it's declared here. Okay, so you can later I'll show you how you can write your own with the notes so that you don't need to remember the frequency. Okay, so this one it says Piezo 9. So Piezo Buzzer is on pin 9. So if you not want to, you can actually swap this to pin 8. I'm just gonna put this on pin 8, and then I'm gonna flash this in. Okay, so I'm gonna plug this in now. Yeah, I just want to get ready so I don't hear the Super Mario again. Oh, okay, uploading already. So oops, I think I shouldn't touch the wire. I'm gonna try again. Unplug. Yeah, I'm gonna try it again. So see whether can play properly. Okay, it works. I'm gonna unplug. Okay, so you can find your own and then do this. Next, I'm gonna just show you how to actually play your own tunes. So open libraries. No, let's see. It should be under digital tone. Okay, we're not using tone keyboard. I just use the tone melody. Okay, tone melody. So the key is that you want the pitches.h. Okay, this is what you want because these are all the tone that you can use in your tone melody. So you just need to include pitches.h, and then after that when you call the tone and time, you just need to put in the notes. Okay, you just need to put a note in, and you put in the duration you want. Okay, unless you want to modify this. If not you can just use this tone 8. You just put in the notes here, then you adjust the delay, and this delay it should be the same. It should be the same with the one at the top. Okay, and then just plonk them in. Okay, so you can, if you just want to play a tune, you don't need this, you just plug in this, and you just put it here. That will work. So that's the end of this lesson. I think I covered everything. Yep. Okay, so that's it for this lesson. Thank you.